Namaskar, welcome back. So, this was the last discussion we had in the previous lecture, that how the absolute motion can be understood in terms of the plate tectonics, and the example comes from the Hawaii chain of islands. So, uh, this is what they identified as I have already discussed in the previous lecture, that they see that there is an active volcano and what they call the big island, and the earthquakes are only occurring in that area, and rest of the islands which are the part of Hawaiian archipelago are inactive. So, they got the ages, and what they identified was that this process is of course not very fast, depends on the velocity of the plate. So, it remains like the portion of the plate remains above the hot magma chamber for millions of years, and then it moves further ahead. Okay. So, what they found was that is as you move away, that is away from the big island, then you see that they are this volcanic island chain, or the volcanoes are older uh, with compared to the activity which is going on here. So, this is a schematic diagram which shows about the hotspot which is anchored below, and that is the source for the volcanic eruptions in Hawaii Islands. So, the Pacific plate has moved northwest over the Hawaiian hotspot, and resulting in a chain of volcanic islands, and we can also call that as an sea mounts. But at a particular location, what they found that it is not in this straight line, or as we see now. Okay, there is a clear cut change in the direction over here. Okay. So, the edges of the mountains are consistent with the plate moment, that also they were able to identify, and that is about 100 millimeter per year. And there is a sharp change in the direction which has been dated around 43 million years back. So, this explains the process is not instantaneous, it is a slow process of the plate movements, and this portion, as you see, it is located in the Pacific plate, where we are having the South American plate here, then you are having North American plate here, and this portion is what we see is the Japan side and all that. Okay. So, this is in the Pacific Ocean, and the plate motion can change, okay, or the direction of the plate can change, okay, and even that, as I mentioned, that plate velocity can also change over the time, and that can result into the different pattern of deformation. So, this was one of the best example which also helped in justifying the continental drift theory and the plate tectonic theory. So, now coming to the oceanic convergence, and this we have already discussed about that the when the ocean and oceanic plate converge, the heavier crust, or the whole heavier oceanic plate, which is the older one, because this will become more denser, okay, will subduct below and result into the overall process, okay, and the overriding plate will have the volcanic arc, what we call, and the portion behind the volcanic arc, that is towards the away from the subduction zone, that will be termed as back arc basin. There will be some sort of sagging there, which will result into the formation of depression, and that is known as your back arc basin. So, the example of the oceanic convergence is you are having Himalayan islands, Japan, you can see West Indies, Philippines, Indonesia, and Central, America. Now, about the trench part, because at the end we will also talk about that what are the two different type of uh, trench. Okay. So, one is like I will mention here is one is the Mariana Trench type subduction, and another is your Chilean uh, uh, trench type subduction. So, this is the place on this planet which has resulted into the formation of a trench which is the deepest point on earth, and that is here 11,035 meters deep. So, one side we have the tallest, and that is your Everest, and uh, and that is the highest point on the earth on this planet, and this is the deepest portion, and this trench is between your Philippine plate and Pacific plate. So, if you look at the Google image of the Mariana Trench, then you can easily compare the dark portion and the topography here which has been developed similar to, but definitely this is much deeper as compared to what we saw in the between the Nazca plate and the your uh, South American plate. So, this is the topography, subsurface topography what we see. Okay. So, we have like the deformation of, if you see, this is the back arc basin area, and you can see the formation of sort of an wedge, and very much similar to what we see in terms of the collision zones also. Okay. Now, these are the regions which will trigger into, like, if there is an earthquake and sudden displacement between the two plates, that will result into your tsunamis. So, example was there, for example, the 2004 tsunami which was been triggered uh, along the Sumatra Andaman Trench. So, coming to that part again, we have the trench area over here. So, this portion is deeper, but here we have the shallower portion. Okay. So, this is again the subduction zone boundary between the oceanic plate here and the oceanic plate on this side. Okay. And we also see that there is an volcanoes along the Sumatra islands. Okay. And only one active volcano is been there in, which is in the Indian side, is the Barren Island. So, this was the pattern of seismicity and the occurrence of the earthquakes which you can see along the trench area, and these locations are the two locations of the major earthquakes which were been triggered. So, this was the main earthquake of 2004, and another was been triggered immediately after that in close to Great Nicobar. And coming to the continental convergence, so what we see is one of the best example so far, what it has been understood, okay, based on the sediments and the signatures of the volcanic rocks and all that, and these examples can be linked with your Himalayas. Okay. So, before the two continental plates, okay, that is, for example, the Indian plate and the Eurasian plate or the Tibetan plate came closer to one another, and there was a collision, and that resulted in the formation of mountains and all that. But before that, there was an oceanic plate, that is what we call the ancient oceanic plate, which subducted below. So, still there is some drag of the continental crust, even though now it is in collision form, but there is some drag which exists between the Indian plate. And so, if you consider this as an Indian plate and this is an Tibetan plate or Eurasian plate, so there is some drag between these two plates which is going on, and that was because of the subduction which initiated with the oceanic plate. So now when two continents meet head on, neither subduct because they are both are of similar density and all that. Okay, so none of them will subduct, but because of the continental rocks are relatively light and like two colliding iceberg resist downward motion, there will be a push or buckling up of the material uh, in that region, resulting into the formation of gigantic mountains. Example is your Himalaya. Okay. And so type 3, you are having the convergent margins, collision zones. If you take, so collision zones that marks the closure of former ocean. Okay. This is another example which the evidence which was been found that we had an ocean. So what was the signatures for that? We are having the oceanic deposits or marine deposits. So marine rocks or the deposits are the testimony that there was an ocean way ahead, like before, or we can say they ahead of the continental plate. So the example is the Alps, the Himalayas, and the Appalachians. So these are the three best examples on this planet, which talks about the convergent margins and collision margins. Okay. So continental collision, if we take about the Himalayas, then there was an oceanic plate which started the subduction, and that resulted into the formation of volcanoes at that point of time. That is, the collision uh, uh, timing is been said at around 50 million years. Okay. So before that, there was the oceanic plate was subducting below the continental plate, and we had volcanic like activities which was been observed at that point of time. So let's see how the formation of Himalaya started. Okay, and as I was mentioning that uh, the in the front of the Indian plate. Okay, so this is your Indian plate. So in the front of the Indian plate, there was oceanic crust that resulted in the subduction and the volcanoes on the overriding plate. So this is your Tibetan plate, or you can also say Eurasian plate. Okay. So we had volcanoes before, and of course, based on the sediments or the marine rocks and the volcanic rocks or the igneous rocks, this uh, uh, theory was got the justification that yes, initially we had this sort of a configuration, because this was happening 50 or more than 50 million years back. So nobody was there at that time, but this is the reconstruction which has been done based on the evidence of the volcanic rocks and the oceanic sediments. So we had the oceanic plate in front of the Indian plate, and that resulted into your subduction. And slowly, because there was a motion that what we have been talking about, that the Indian plate was moving towards the Eurasian plate or the Tibetan plate. Okay. So there was the deformation of this marine deposits or the oceanic rocks. Deformation was also seen over here, and at the same time there was closure of ocean. Next one, finally, what we see is that when the two continental plates came close to one another, no feed or the ingredients were being feeded for the volcanic eruption. So this stopped. Okay. So no volcanic eruption now after the breakup of this lithospheric plate, oceanic lithospheric plate. And then there was the basin which was formed, and that basin is your Indo-Gangetic plain. Okay. Close to that in the foothill zone of this region, and this is quite deep actually, because what we learn in the subduction, that we will have trenches, okay, formation of the deeper portion between this two area, and that resulted into the deeper uh, deep basin which was developed between that. Okay, so the closer of the two, the ocean, and then the collision. So that collision is been termed as, or where the two plates collided, is termed as suture zone. Okay. And then the activity started, which resulted into the mountain building activity. So Himalayas, or we can say Himalaya, is the result of two continental crust collision. Okay. But initially there was subduction which occurred in the past. Okay. So for again the if you look at this part here, so we had an oceanic crust which subducted below, and there was a development of wedges, okay, and that what we call accretion prism. Okay. So this deformation started over here, and then finally we have the formation of Himalayas. Okay. So in this region, mostly, because now what with the present configuration, if we if we consider that, okay, so what we see is mostly shallow earthquakes, okay, mostly shallow earthquakes, wedge deformation at the contact near the surface we will see, and that's how we have multiple weak zones in this area. So the Himalayas, again the story which starts from the drifting of the Indian landmass, which was located far away in down south of equator, and it moved again. This shows that, okay, that there was change in the direction of motion. Okay. And there are within the Indian plate, we have volcanic rocks also. So from where those volcanic rocks came in this area as well as in this area. So that question we will answer later on. We'll talk about that. Okay. So whether there was similar story what we saw for the Hawaii Island. So that also may be there, but let us keep that as a question. Okay. But this sketch, it shows the how the Indian plate moved its journey, or it started its journey way south of where it was located, way south of equator, and then how it moved and presently it collided. Okay. So what was been deciphered from the the rocks and all that, that about 80 million year ago, India was located almost like 6,500 to 7,000 kilometers south of the Asian continents. Okay. Moved northward at a rate of 9 meter a century. Okay. So that is almost in 100 years. Okay. Indian plate collided the Asian plate, or the Eurasian plate, or the Tibetan plate you call, okay, at about 40 to 50 million years back. And that showed that the movement slowed down by almost half because of the collision. And that was the time the mountain building activity started, and the rapid uplift of the portion in that area resulted into the formation of Himalayas. So they associated this decrease in the velocity rate related to your collision. So the mighty Himalaya, which is almost like 2,900 kilometers, is a creation of plate tectonic forces or plate tectonic motions, okay, which is related to the continental collision. Now this is the portion which is again which talks about that how this faults have been formed, and how the deformation started after the collision, when the Indian plate intruded the Tibetan side. Okay, so this is the part which talks about that. So this is the cartoon which explains that how the Indian plate, after it collided with the Tibetan plate, or the Eurasian plate or Asian plate, we talk about how the deformation pattern was created. Okay, so we have on this side, because this plate has moved like this in the Asian and intruded in the Asia. So we have a formation of the fault systems. Okay, in this area, again, this is the trench part or the subduction zone part, and this was the initial subduction and then resulted into collision. But this portion on either side, that this one and this portion, they are sliding actually. Okay, so anyway, we'll stop here, and we'll have more discussion on this part in the next lecture. Thank you so much. Namaskar.